Hi, today I'm going to present the core claims of a work-in-progress paper on the empirical inadequacy of grounding orthodoxy. So what is grounding? As I shall understand it, grounding is a form of non-causal determinative relation among entities with explanatory import. We can say that if an entity A grounds an entity B, then A non-causally determines B. And we can specify the explanatory import of grounding as follows. If A grounds B, then A explains or help explains B. Let us consider a few examples. These examples are formulated in terms of facts but can be rephrased for other entities. The top one, the fact that Michelle Obama exists, grounds the fact that her singleton set exists. The grounded theorist would say that the fact that Michelle Obama exists grounds and therefore explains why her singleton set exists. Second example, the fact that an electron is negatively charged grounds the fact that it is disposed to repel other negatively charged particles. The grounded theorist would say that the fact that an electron is negatively charged explains why it has the disposition to repel other negatively charged particles. And lastly, an example from logic. The fact that P and Q, so this is a conjunction, is grounded in the fact that P and in the fact that Q. So here is the view that conjunctions are grounded in their conjuncts. On the orthodox view, grounding has three structural properties. First, it is irreflexive. This means that there is no thing that grounds itself. Secondly, it is asymmetric, which is to say that it is never the case that two things are each other's grounds. And lastly, grounding it is transitive, which is to say that if we have three things, say x, y, and z, then if x grounds y and y grounds z, then it's also the case that x grounds z. So what's the problem? Science suggests that there are plausible instances of symmetric grounding in nature. However, on the orthodox view, grounding is asymmetric, and therefore I contend that the orthodox view is empirically inadequate. To solve this problem, I propose that the seeker of the naturalistic theory of grounding should embrace what I call mutuality. This is the thesis that says that for some things, say x and y, it is possible that x grounds y and y grounds x. Said differently, on the mutuality thesis, it is possible that two things can be mutually grounded. Here's what I'm going to do next. First, I will give you a very short overview of a naturalistic theory of grounding. Then I will discuss the case of quantum entanglement. As I shall explain, the mutual dependence among entangled components cannot be accommodated satisfactorily in terms of the orthodox view of grounding. I will then discuss two strategies that might allow the grounding theorist to preserve the asymmetry of grounding relations in the case of entanglement. However, I will point out that both strategies have some serious problems. And so I will conclude by pointing out that the acceptance of mutuality could be a better option. So let me start by saying something more about a naturalistic theory of grounding. Minimally, it is a theory that is compatible with fundamental physics, and the features of the grounding relations are informed by empirical findings. This is to say that instead of stipulating that grounding is irreflexive, asymmetric, and transitive, the choice of the logical features of grounding will be informed by what science tells us. And this will become clear in discussing the case of entanglement. Given what I've just said, a naturalistic theory of grounding should be able to account for dependencies in quantum theory. And here's the case of quantum entanglement is particularly relevant. Quantum entanglement is the distinctive phenomenon of quantum theory. What is interesting about this case, at least for the purposes of developing a naturalistic theory of grounding, is that the relations among entangled entities, such physical particles, do not seem to be satisfactorily explained in causal terms, namely in terms of causes and effects. The relations among entangled entities are non-separable and modally loaded. Now, it seems that grounding is a plausible candidate for explaining the dependencies that hold between entangled components. The components of an entangled state display a unique behavior. They are jointly constrained in a way that it is possible to predict with certainty, given the quantum formalism, how a certain component will behave, for example, in terms of the physical properties that it will display, by considering measurements that are carried over on the other components. And the same is true for the other way around. So here's an example. Consider an entangled states of two particles. Here you have a formalizations of this state. Now, these particles are arranged in a way that the total spin of the system is zero. Physics tells us that the singlet states supports considerations of the following form. If particle 1 measures spin up, then necessarily particle 2 measures spin down. And if 1 measures spin down, then necessarily particle 2 measures spin up. The same is true if we replace particle 1 with particle 2. So if particle 2 measures spin up, then necessarily 1 measures spin down. And if 2 measures spin down, then 1 necessarily measures spin up. A plausible grounding account of quantum entanglement should be able to capture the mutual dependence between entangled components. In this particular case, we should be able to capture the systematic anti-correlation dependence between the spin values of particles 1 and 2. To accomplish this aim, the grounding theorist could invoke asymmetric relations between particles 1 and 2. For example, we could maintain that the fact that particle 1 measures spin up is at least partially grounded in the fact that particle 2 measures spin down. And mutually, the fact that particle 2 measures spin down is at least partially grounded in the fact that particle 1 measures spin out. The same would go for opposite spin. To clarify, the notion of partial grounding can be explained with an analogy with explanation. Like we can distinguish between complete and partial explanation, we can distinguish between partial and full ground. A full ground is akin to a full explanation of a certain fact. A partial ground, instead, is a contributory part of a full ground. Here on the slide you have a more precise definition if you are interested. Now let's return to the case of quantum entanglement. So it seems that if we want to give a satisfactory account of the mutual dependence among entangled components, we need to invoke asymmetric grounding relations. In this particular case, it seems that we have a symmetric grounding relation between the spin values of particles 1 and 2. Of course, this case generalizes. For in fact, we can imagine a similar case for other qualitative properties of other entangled components. It appears plausible that a satisfactory grounding account of entanglements demands the acceptance of symmetric grounding relations to capture the mutual dependencies among entangled components. If that's correct, then it's bad news for grounding orthodoxy. Why? Because on this view grounding is asymmetric, and therefore we cannot accept that entangled components are mutually grounded. Now, this is not a problem for the grounding theorists who embrace the mutuality thesis. Recall that this is the thesis that grounding is sometimes symmetric. Therefore, if we endorse mutuality, then we have no problem in accepting that sometimes, for example in entangled states, there are symmetric grounding relations among entities, for example among entangled particles. However, we might wonder whether there are any strategies that the grounding theories can invoke to preserve the asymmetry of grounding and yet account for the dependencies among entangled components. As it happens, there are two strategies that could serve this purpose. The first one is the appeal to structuralism, and the second one is the appeal to holism. I'm going to sketch briefly these strategies in what follows. As it will become clear, both strategies have some problems, and therefore my conclusion will be that the acceptance of the mutuality thesis is a preferable option. Let's consider ontic-structuralism first. This is the view that physical relations are prior to their latter. How can we account for entanglement in terms of grounding? If we adopt structuralism, we can maintain that entangled objects and their properties are asymmetrically grounded in fundamental entanglement relation. To illustrate, let's consider the previous case. So remember that we have two particles that are entangled with respect to their spin. The ontic structuralist could maintain that the fact that the spin values of particles 1 and 2 are systematically anti-correlated is because these particles are asymmetrically grounded in some fundamental entanglement relation. For example, the relations of having opposite spin. Now, there are two problems with this strategy. The first one is that the structuralist approach relies on a controversial reading of quantum states. Now, this point is articulated further in a forthcoming paper by Calozzi and Morganti. There's a second problem. It is not entirely clear whether relations such as that of having opposite spin 2 or more generally relation of having incompatible quantum numbers are indeed genuine. So if we adopt the structuralist strategies, the grounding theories should also give us a justification for believing in the reality of such entanglements relations. Now let us consider the holist approach. If the grounding orthodox embraces holism, they could maintain the quantum entangled components are part of an ontologically prior whole. We can unpack the priority of the whole by saying that the state of the whole determines the states of the parts. In terms of grounding, we can account for entanglement by saying that entangled objects and their properties are asymmetrically grounded in the whole composite system that has these objects as parts. To illustrate, let's consider the previous example. Recall that we have an entangled state of two particles. The particles are entangled with respect to their spin. The holist would say that the particles are parts of a composite system, and the composite system in question would be the singlet state itself. Crucially, what grounds the features of the particles, for example, the fact that they display systematic anticorrelations with respect to their spin values, is the singlet state itself. Now, this view might allow the grounding theories to maintain the symmetry of grounding. However, it raises a couple of problems. First, holism requires us to regard the relations between entangled parts as monadic properties of the quantum whole. However, not all relations among entangled parts are satisfactorily interpreted as monadic properties of the quantum whole. Take, for example, two particles having a certain distance. So this is a relation between two entangled parts. The holist should say that these relations of having a certain distance is a monadic properties of the quantum system itself. But this seems to amount to the claim that the quantum system itself has a certain length. Now, whether or not it is plausible to claim so, it seems that we are losing precious information about the parts of the entangled state. The second problem is that it's not clear whether holism can account for subtle features of quantum entanglement. Unfortunately, here I have no time to address this problem in more details, but you might have a look at Calosi and Morganti-Foucault papers, where these objections is further developed. It is time to wrap up. I've considered briefly two strategies that would allow the grounding theories to preserve the asymmetry of grounding and therefore the orthodox view, and yet account for entanglement. However, I pointed out that both strategies raise some important worries. So it seems to me that embracing mutuality, the thesis that grounding can be symmetric, is a more favorable option for accommodating possible symmetric dependencies among entangled components. Another advantage of mutuality is that it permits coherentism, the view that entangled states and the components are mutually grounded. It is important to note that mutuality is compatible with both ontic structuralism and holism, so I'm not claiming that these views are false. For example, someone could maintain that entangled components are symmetrically partially grounded in each other and yet asymmetrically grounded in the entangled states, where the state itself can be regarded as a fundamental entanglement relations, like the ontic structuralists would say, or as a whole composite whole, as the holist would maintain. However, if we embrace the possibility that grounding can be sometimes symmetric, so if we accept mutuality, the logic of grounding dictates a choice between two conceptions. One is that the grounding is irreflexive and not transitive, and the other is that grounding is not irreflexive but transitive. However, it should be clear that the choices between these two conceptions on a naturalistic theory of grounding will be informed by science. I will devote a future work to investigate which of these options we should embrace. Of course, I've only presented the core claims of the papers. A lot of issues requires more careful considerations. Feel free to get in touch if you want to discuss some of them. Thank you for watching.